Okay, welcome back to macroeconomics. So this is the final week of the choice and demand topic. Let's start. There are two important aggregations which have something to do with the budget line and elasticity. So the first one I wrote down here already, the Engel's aggregation, which has to do with the income elasticity. So at one point I already mentioned that we have Engel's law, which says that when income increases, the consumption of food, here for example Y, will also increase, but with lower rate. And the budget share for food will decrease. So in elasticity term, that means the elasticity of Y with respect to income smaller than 1. That means when income increases by 1%, the consumption of food will also increase, but increase less than 1%. And the Engel's aggregation says that because of this, the income elasticity for all other goes together in one, let's say, composite will be larger than 1. How can we prove that? We could prove that by differentiating the budget constraint with respect to I. So let's write it down here. We would have the derivative of I with respect to I on one side, the other side, the derivative of X with respect to I. Here in this case, let's write it down. It's implicit here is X is the function of Px, Py, and I. Similarly, Y, Px, Py, I. That is the initial maximizing points already found, right? And the individuals already know the combination that would bring them the maximized utility. And that's why it's a function of price and income. So implicit here, because there's I in the X, it would be dx over di, right? And then times px plus similar for y, dy over di times py. And what is the derivative of I with respect to itself? It is 1 equals, let's write the constant in front so it's more convenient to see something later, times the derivative of x with respect to I plus py times the derivative of y with respect to income. Okay, let's call it start. Now, so intuitively, let's say if you get $1 more extra of income, then you will spend this amount on extra x and this amount on extra y, because the derivative with respect to income says how x change when you have 1 more unit of income, right? And the times px, that means it's the expenditure, so it's the extra expenditure when income increases. Alright, so because I said that the statement has something to do with the income elasticity, so we need something else for the elasticity. For example, here You know, by definition, the elasticity of x with respect to income must be this derivative but times, let's write it down over here, small. So the derivative of x with respect to I times I over x, right? And this is the elasticity of income of x with respect to income. So here we already have the derivative. We need this term I over x. We have to multiply it there. Similarly, here we still need I over y, right? But we can't just simply multiply it, because then it will change the nature of the equation. So that means if we multiply it, we also have to divide by it at the same time. So as the result, you would have multiply by I over x times x over I, right? And similarly, for the second summand with respect to y, that is I over y times y over I, right? To get, and on the left hand side, is there anything changed? Nothing changed, right? Because this is 1, this is 1, multiply everything by 1, nothing changed. So on the left hand side, still 1 remain the same. Now let's do it step by step. So we have px times the derivative of x with respect to I times I over x times x over I again, right? Plus py times the derivative of y with respect to I times I over y and times y over I again. Now we will get the income elasticity, which is px times, this is the income elasticity of x, so that is a x with respect to I times, there's still one x over I left, right? Plus similar, this is the income elasticity of y with respect to I times, let's write clearer, y over I, right? Now what is this? You have the income elasticity and you have the remaining is px times x over I, which is the budget share, right? Budget share of x, denoted as the small x. I would write it here, budget share of x times the elasticity again with respect to income, plus similar here. So the budget share of y, food, times the income elasticity of food with respect to income, right? This is what we should have. So you can already put the term with respect to food on one side and see what happens. So that means we have 1 minus as x, the budget share of x times the income elasticity of x equals the budget share of y, food, times income elasticity of food. Now, And now remember, we have the income elasticity of food smaller than 1, right? We want to make use of this to prove something else. And this also means we could put also like divide both sides by the income share or expenditure share of food, of wine. And we have the elasticity on one side. So that means 1 minus the budget share times the income elasticity of X, right? Over the budget share of Y equals the income elasticity of Y. And we know that this term is smaller than 1, right? Because of this. Engel's law. By the way, Engel's law is an empirical statement. That means proven by many empirical studies. So it's nothing that started from theoretical models, but it's first proven by empirical studies, and then later researchers follow up with the theoretical background. Okay, so that means we have, because of this inequality, we have 1 minus Sx times elasticity with respect to income divided by the budget share of food smaller than 1, right? And now our objective is to put the elasticity again along in one side. We could do that first by multiplying both sides by the budget share of Y. So we would have 1 minus Sx times Exi smaller than Sy, right? Because Sy here is positive, the budget share positive. So if you multiply a positive constant to both sides of an inequality, then the sign remains the same. No? And then you could switch these two guys for one another on the other side of the equation, the inequality. So that say that 1 is minus Sy is smaller than the elasticity of X with respect to I times its budget share. Okay, so I clean it a bit here so that we have space to finish it. So let's start with where we stopped. It's here. Let's say that 1 minus the budget share of food must be smaller than the income elasticity of everything else, which is represented by X. So it could be clothing, entertainment, sport, everything else composed in one X. Now, with respect to incomes, time is budget share, right? And that means now we could also divide both sides by the budget share, so that we only have the income elasticity of everything else, which is the object or the subject of the statement on one side, and see what happens now. So that means you have 1 minus budget share of of y over budget share of x, smaller than the income elasticity of x, right? Now, watch out the term on the left-hand side. What? Remember, the budget share of every goods, here in this case only 2 goods, x and y, must sum up to 1. So that means 1 equals sx plus sy, right? And if you have 1 minus sy, it must be sx on the other side, right? Because of this, you would have here, this term is just the budget share of x, right? So sx over sx, again smaller than the income elasticity of x, which is everything else, and that is, here is 1, right? Okay, and this is what stated by the Engel's aggregation. So please don't ask me why we are deriving this. Now we just try to prove something that's stated by some economists and to understand why they say what they say. That is also an important part of the learning of theory. Now, the second aggregation is the Cournot aggregation, which says that the sizes of gross price effects are restricted by the budget constraint. How do we understand that? How should we prove it? Let's do. So now, again, to understand this statement, we still can take the derivative of the budget constraint, both sides. But because it has to do with the cross price effect, we don't take it with respect to income anymore, but with respect to px. Now, and before we start, remember again that x and y over here is still x, the function of px, py, and I. And y is also still the function of px, py, and I. Now, so what happens when we take the derivative of both sides? Let's see. So the first thing is derivative of income with respect to px equals. So here you have px here, but you also have px in the x. So actually that is the product rule. So we first take the derivative of the first term px, which is 1, right, with respect to itself. But let me write it down. Write that px x of px, py, and I with respect to x, px, sorry, plus the derivative of y, because py here is a constant, px, py, I here, right, with respect to px again, and times py. Okay, that's the idea. Now, product rules, saying the first the derivative of the first term times the second term. So that means we have the derivative of px with respect to itself, which is 1. So at the end we will have x. By the way, on the left hand side you have 0 because I is a constant, right? So x, then plus, let's skip this annoying part there, we don't need it anymore, right? So plus the first term px times the derivative of the second term, which is the derivative of x with respect to px. This is for the first term. And then on the second terms, you can just rewrite it again. Py times dy over dpx. Now, that's the first step. Now, to see how it's bound to the budget constraint, we need the budget share. Then we need also the cross price elasticity, but let's do it step by step. So let's have a look at this. You need the budget share. The budget share is something, for example, as x equal x times px over I, right? So here you have x. You need px over I, right? So let's first of all multiply every summand by px over y. And because the other side is just 0, we can just rewrite it. Nothing changed over there. So times x times px over I, now plus px times the derivative of x with respect to px times px over I, right? Plus py times the derivative of y with respect to px again, and times px over I. So here you have the budget share of x. Let's say first thing, solve like the budget share of x plus. Now get a bit more complicated, think about it. So we would have over here, we need the next step is elasticity, right? So this looks already like the all-price elasticity of x, but then we need 1x in the denominator, right? But if you have 1x in the denominator, you also have to put another x on the numerator so that the equation remains unchanged. So there for the second term, you multiplied everything by x over x equal 1, right? Nothing changed. The next term with py, you already have this, looks similar to the cross price elasticity already, but then because it's here's the derivative of y, you would need 1 y in the denominator again, and because of that have to multiply another y on the numerator, which is 1 for the same reason. So let's do it step by step. So we have px times, let's say, put yi over there, like in front, because we don't need it anymore. And we have the derivative of x with respect to px times px over x, then times another x. what we just said here, right? Similarly, for the next term, we would have, py, take I in front for the moment, times the derivative of x with respect to, not x here, no, x should be y with respect to px times px over y here, then times y again, right? Now let's convert it to the elasticity. So we have rewrite it again, because we haven't done anything, everything is just multiplied by 1, so we don't have to change this first term, right? So plus, let's put x in front. Think about it. X times px over y. What is that? It is the budget share of x, right? Times the own price elasticity of x. This elasticity with respect to its own price. Plus, similar, you have py over I times y, which is exactly py times y over I equals s y, right? The budget share of y. Okay, let's rewrite it. Times the elasticity. What is the elasticity now? We have y, but with respect to px. So that's the cross price elasticity of y. Okay. Now, everything together equals 0. How should we do it further now? Okay. So you could put the budget share of x along to the other side. That means, so here I should have equivalent as the side of equivalent, right? Or meaning something. So meaning minus sx equals sx plus times this own price elasticity plus the cross price elasticity of y times this budget share. Okay. Now what does this step here tell me? It tells me that the weighted effect of changes in px on all goods, including itself, like inside this all price elasticity, right? And the cross price effect on y. So the effect of changes in px on x and on y, weighted by the budget share, because all budget shares sum up to 1, right? So it's actually a weighted average of the effect. Depends on the budget share of x itself, right? Because you have minus sx on one side. So, but the budget share is again something you can derive or you can extract from the budget constraint, right? It depends on the budget constraint. So that's why they said the sizes of cross price effects are restricted by the budget constraint. It will not go beyond that of the budget constraint of x. So this actually can be generalized for the cases of many more goods. Now, you could, for example, just add more term to the right hand side with the budget share of another good z times is cross price elasticity with respect to px, and so for many cases of good. This is actually especially useful when the first thing why we concerned about elasticity here, as you go further in your master program, you will see that actually a lot of time with modeling and with econometric estimation is much more convenient to use elasticity compared to the derivative of itself. The second thing is it's convenient in case you want to find one of those elasticities. So this equation will be something that help you, that you could use at the end. For example, if you wanted to find the cross price effect of one of those goods, and you have everything else. So that's the application of it.